We are now at lesson 14C, conclusions in observational. I knew it was going to do that. Conclusions in observational studies. A college student needs to know, or no, a college needs to know if students would support a $50 fee increase to improve library facilities. A college researcher gathers 250 students selected randomly for the survey using the college database. And something that was said in class today, I think bears repeating here, our lessons are set up so that not all of this is testable or can be on the test, but it's set up to help you to learn more deeply that the concepts that we are looking at. So we're going to be looking at a college and what they're going to do to decide, would the students do the $58 increase, or and we'll keep looking at other studies, trying to ingest and make the words that we're talking about more meaningful. So the students were asked the following. This is what they were asked. The library, if somebody wants to turn the music on in the background, the library is a vital part of your education. It is your source for research. Would you support a small fee increase to improve its facilities? And of those surveyed with that question, 73% supported the fee increase. Question number 1, what is the sample in this case, and what is the population? So looking at all the information that's been given to us, the sample would be the 250 students who were surveyed. The population would be all of the students at this particular college. So the objectives for this lesson are that we will understand that researchers can design their studies to minimize the impact that bias can have over their results. Researchers can make conclusions from observational studies, conclusions that describe the relationships between the variables. I'm going to put this next part in red. These conclusions may not conclude or include cause and effect. They may not when you're doing an observational study. When we're done with this lesson, we're going to be able to identify, and I would highlight, underline, put sticky notes around these pieces on what we're going to be able to do. We'll be able to identify key elements of a research design that may introduce bias. We're going to be able to suggest corrections to a research design that can minimize that bias. We're going to know or be able to identify appropriate conclusions that we may state for an observational study. And we'll also be able to make appropriate conclusions from these observational studies. And that's the inappropriate, that's the appropriate. Question 2. Every statistical study seeks to answer a research question about a problem. Carefully reread the 2 opening paragraphs above and then answer the following questions. Reread these 2 paragraphs. So go ahead and hit pause. They're the ones I had on the last screen. Reread those 2 paragraphs about the college wanting to know something, and then what the question is that was asked. And then after you get through doing that, come back and let's start at part A. The question being, what question were the researchers seeking to answer? Make sure your question is directed toward a population. So something like, would students at this college, whichever college it is, if we knew the name, we'd put it right here. Would students at this college support a $50 fee to improve library facilities? Would they? That's our question. Part B, will the results of this particular survey yield a valid answer to the research question, and explain yourself? And I don't know how large I can write this, but no conclusion can be made from this study because the wording of the survey question was biased. It was misleading. And so everything that we are doing, everything that we have done so far is rendered useless once something along the lines of a survey question being biased is introduced. So moving on to part C, if the study gives a valid answer to the research question, give a conclusion. If not, explain the problem, explain how the data are non-representative or biased, and propose a solution. The bias is in the response or measurement. It's response or measurement bias. The question is being asked in a way that is one-sided. No reasons are given for not supporting the fee. The question needs to be more balanced, simply just asking, would you support a $50 fee to fund the library? Period, end of story. Moving on, question 3. A graduate student gathered 75 local high school student volunteers to estimate the number of hours that United States high school students spend studying every week. On average, the students in the sample spent 12 hours a week studying. Part A. And if you haven't already hit pause and have already worked on this, then stop where you are, hit pause, spend some time thinking and reflecting on these questions, and then come back and we'll talk about part A. So in part A, what question is the researcher seeking to answer? Make sure that the question is directed toward a population. So the question is something like, how many hours do United States high school students spend studying each week? Okay, you got to start with a good question. Part B, will the results of the survey yield a valid answer to the research question and explain your thoughts? Will the results of the survey yield a valid answer? No. Notice here that we have some volunteers. And remember earlier, if something is awry even early on, what we end up getting is going to be useless information. So are the results going to yield a valid answer? No, we have biased data. Part C. If the study gives a valid answer to the research question, then let's give a conclusion. If not, let's explain the problem, like explain how the data are non-representative or biased, and then propose a solution. Because this study consisted of volunteers from a local high school, oh, double whammy. Volunteers local is that representative of the United States. The data contain selection bias. The graduate student needs to select a representative sample from high schools all over the United States. A random or a stratified sampling process would be useful. We have one more study to look at in this lesson. Question 4. A study at the University of Wisconsin in Milwaukee followed teens who smoked marijuana for years. The director of neuropsychology, Krista Lisdahl, found that teens who began using marijuana and continued for many years lost about 8 IQ points from childhood to adulthood. Part A, what's the question that the researcher is seeking to answer, and make sure that this question is directed toward a population. You need to try to write your question. So go ahead and hit pause, Write your thoughts on what the question is, and then come back and let's finish up the lesson together. A possible question could be, what effect does smoking, I'd like to put in marijuana, have on teens who begin and continue to smoke after many years? Whew, but I think we got it all in there. Part B, still on question 4. Can we conclude from this study that many years of marijuana use from childhood to adulthood, let me put this in red, causes an individual's IQ to decrease? Explain why, or offer an alternative explanation for what was, let me put this one in red too, observed. So looking at some thoughts on part B, let me go ahead and change color again. And let me put some asterisks around this word. When we are looking at an observational study, we may not, no way, no how, use the word cause. And so with that not being appropriate, there may be another variable causing both the IQs to drop and for the marijuana use to increase. Education could do this. As students continue in their education, their IQ may increase, and the likelihood to use marijuana may decrease. And it's just interesting to even wonder if increased education would cause marijuana use to decrease. Write down your thoughts. There could be many ideas, reasons why. Throw down something. Write your thoughts. It could be situational, it could be family, it could be emotional. A lot of things could be going on. But one thing we cannot say is that in this observational study, that marijuana use caused a decrease in IQ. So moving on to C, now that I've harped on that one forever, what conclusion can be made from this study regarding marijuana use and IQ? We can say that marijuana use from childhood years into adulthood is associated with decreased IQ. And we talked about in our face-to-face class today about having some what I called frou-frou words, where we have words like seems to, or phrases like seems to, appears to, and a lot more that the students came up with on words that are generic but are still being descriptive, that it does seem that marijuana use is associated with decrease in IQ. But one thing we cannot say, one more time, is we cannot say that the marijuana use causes a decrease in the IQ. So let's finish up this lesson. Question number 5. What are the characteristics of a well-designed study? So a couple of things you should write down. I'll just put RQ, research question. You need a really, really good research question. When I was working on my dissertation, we spent forever crafting our research question before we got started on what we were doing. We needed to know what we needed to know or wanted to know before we even started trying to look and find articles and ideas to go along with a well-crafted research question. We also need to decide, if you're doing a study, are you going to do an observational study or experimental study? Which one are you going to do? My dissertation was observational. I did not do an experiment. I looked at students in our Math 0310 class, And I looked at the data, not even the students. I looked at the data to see how they performed in the college algebra class and if there were factors that appeared to influence how they did in the following course. Another thing we need to look at when trying to do a well-designed statistical study is we need to try to minimize our error, our sampling error. And let me put sampling. And in this minimizing the sampling error, one thing we can do is choose what we call a good N, N being the number in our study. If we have 10, that's not going to be very representative of like the state of Texas. But if we could do maybe a couple of thousand, that would increase the validity of our study and would help to minimize the sample error. Some other things that we can do for a well-designed statistical study is to try to minimize bias. To minimize bias by doing a couple of things like ensuring that we have representative samples or a sample, and also that what we're designing, the process, that what we're doing in our research is really viable, it's really doable. Those need to go away. Just spending some time, a whole lot of time and thought. And y'all may decide to go into graduate school, and there you would be in a statistics course and you would be looking at how to design a study and implement a study. Right now we're just scratching the surface to give you an idea of very important factors in a study. The other thing is for you as an individual to have a healthy paranoia of any of the ads you're seeing on TV for products, or right now we're heading into a campaign season, an election season, but just have a healthy paranoia like, well, how many were even in your study? What kind of study did you do? Was it experimental, observational? Did you have any bias in your study? Just being able to ask more educated questions. So I have a few more thoughts to tell you. These are not on your page. These are just some thoughts I want you to jot down and add into this lesson. So a couple of things that we are looking at is, where did I write it? Purpose. When we are looking at a purpose of an observational study, the purpose is to infer to a population. And we just really have to work hard to get a representative sample without bias. Nothing will ever be perfect, but we need to be very diligent to have a very, very good sample so that when we do get some results, we can infer them to the population. I would like you to write down the purpose of an observational study is to describe a large population and be able to infer to it, but there are also some limitations on an observational study. And the primary limitation of an observational study is that it can only describe what it observes. It can't explain. You've got to be real stone-faced about it. You've got to just report about what you see, and you can't offer explanations. Experimental studies, however, they help us to explain why. And we're going to be talking more about experimental studies, but right now, just make sure you're focusing on and thinking on an observational study. So now, we're going to be really harsh on our studies. We're going to be really harsh on what we're hearing, seeing, and reading, but balance that with, and you might want to jot these thoughts down too, there is not a perfect study ever. And you report your limitations, you report your errors, you report what's going on. You're honest about what you've done and what you're doing and what happened during the study. And while you're working on the study, you should do your very, very best to minimize all types of bias. And you also should be really careful that when you have results, you should carefully convey them to make it, like, you want to be transparent. You want to make very clear any possible problems with the study's design or with the study's implementation. You just want to be very forthcoming, very transparent, very clear about your study. And that's what I did in my dissertation. I talked about the limitations of my dissertation study, things that we saw, explanations we tried to give, but we were really clear that we had no rationale, just the experience as being professors. But it was not an experimental study, so it was definitely not cause and effect. So as we move forward in our studies, keep that healthy paranoia as you hear news and talk to people and read books and all the things that we do in life. Have a healthy paranoia. No one's perfect, no report is perfect, but go at things with an educated thought process. And we're done. We're done with lesson 14C. Go look at your syllabus to see if you have more to do this week. If you do, keep going. If you don't, whew, celebrate. You've finished another week.